Why does a modern billion-dollar highway rot in just 50 years, while this 2,000 years old Roman dome hasn't cracked once? We've always assumed it was because we have better tools and advanced technology. But the truth is, our modern foundation is fatally flawed, and the secret to why Rome is still standing lies in a lost technology that modern scientists are only now beginning to decode. You are about to discover a 2 millennia-old lost technology that modern scientists recently proved can actually heal itself. And the craziest part, the exact element that is destroying our modern cities is exactly what makes Roman buildings indestructible. We think we are at the pinnacle of engineering. We build skyscrapers that pierce the clouds and bridges that span massive bays. But our modern foundation is fatally flawed. To make concrete strong enough to build high, we rely on a hidden skeleton of steel rebar. This gives the concrete tensile strength, allowing it to bend slightly under heavy winds or traffic without snapping. But this steel skeleton creates a ticking time bomb. Water is the enemy of modern architecture. It inevitably finds a way into the microscopic pores of our buildings. When moisture penetrates modern concrete, it reaches that steel skeleton. The steel rusts, and as it rusts, it expands. This expansion exerts immense internal pressure, literally shattering the concrete from the inside out. Engineers call this phenomenon concrete spalling. It is why our bridges collapse, our highways crumble, and our cities require constant billion-dollar maintenance. Now transport yourself back to the 1st century. The Romans built over 5,000 miles of aqueducts across treacherous terrain. They built the massive amphitheater of the Colosseum. They built the Pantheon, which to this day remains the largest unreinforced concrete dome on the entire planet. And they did it all using absolutely zero steel. We always assumed we knew how they did it. In the 1st century BCE, a Roman architect named Vitruvius wrote a massive definitive treatise called De Architectura. He explicitly recorded the ingredients for their legendary building material, known as opus caementicesium. The recipe seemed incredibly simple: volcanic ash, lime, and seawater. So, modern engineers tried to recreate it. They followed the ancient text perfectly, but the resulting structures were weak. They crumbled easily. The ancient recipe simply didn't work for us. We assumed Vitruvius was wrong, or leaving out crucial details. In fact, when modern materials scientists placed genuine ancient Roman concrete under a microscope, they found a glaring flaw. It was a mistake so obvious that it made the modern world believe the Romans were actually terrible builders. If you slice open a piece of modern Portland cement, it is perfectly uniform. It is a smooth, homogeneous mixture, engineered to absolute perfection. But when researchers sliced open Roman concrete, they found it littered with tiny, bright white chunks. These white nodules are called lime clasts. They are fragments of unmixed calcium. For decades, the undisputed consensus among archaeologists and scientists was that these chunks were a sign of ancient incompetence. Experts looked directly at the secret of Roman engineering and dismissed it as a quality control issue. They assumed the Romans used cheap labor. They assumed the workers were sloppy, failing to mix the concrete thoroughly before it dried. Modern cement is perfectly smooth, so naturally, we assume the ancient, chunky stuff was just an inferior, primitive attempt at what we do today. That arrogance blinded us for generations. It wasn't until January of 2023 that a team of researchers at MIT decided to question this long-held dogma. Professor Admir Musik and his team looked at these ancient lime clasts and realized something didn't add up. The Romans were meticulous engineers. They perfectly calculated the geometry of aqueducts to maintain a subtle, constant slope over hundreds of miles. Why would they suddenly get lazy when stirring the cement? The MIT team decided to formally test this so-called sloppy mistake. They recreated the ancient chunky mixture in a lab. What they discovered completely shattered decades of scientific consensus. Those little white chunks weren't a mistake at all. They were a highly sophisticated, hidden chemical booby trap. To understand how this trap works, we first have to look at the coastline. Roman harbor walls are subjected to some of the most brutal forces on Earth. Ocean waves continuously batter the stone. Salt water eats away at the foundations. A modern concrete seawall requires constant maintenance and repair just to survive a few decades of this assault. But Roman harbor walls do the exact opposite. In the 1st century, the philosopher Pliny the Elder watched these coastal structures with absolute awe. He noted in his writings that Roman concrete, upon hitting the violent seawater, transformed into a single stone mass. He claimed it became impregnable to the waves, and incredibly, grew stronger every single day. It sounded like ancient mythology. But in 2017, a geologist named Marie Jackson from the University of Utah proved Pliny right. Her team discovered that when seawater crashes against Roman marine concrete, it doesn't destroy it. The salt water continuously dissolves the volcanic ash trapped inside the structure. The specific ash the Romans used, called pozzolana, was mined heavily from the Campi Flegrei volcano near the Bay of Naples. When this specific volcanic ash mixes with seawater, it sparks a slow, continuous chemical reaction. This reaction grows rare, interlocking crystals inside the concrete, specifically philipsite and aluminous tubermarite. These are the exact same cementing minerals naturally produced by underwater volcanoes. These crystals act like microscopic armor. They interlock and reinforce the material over centuries. The Romans had figured out how to build seawalls that actually consume the ocean's destructive power to make themselves stronger. But that explains the harbors. The Pantheon is not underwater. The Colosseum is not battered by ocean waves. So how did Roman architectural concrete survive on dry land for 2,000 years without the ocean to heal it? The secret to their land-based empires wasn't just in the raw ingredients. It was in a violent, high-heat process that the Romans deliberately left out of the history books. Remember the ancient recipe from Vitruvius? It called for lime. For over a century, modern scientists assumed this meant slaked lime. Slaked lime is created by soaking limestone in water until it forms a workable, safe paste. It is the standard, traditional way to make modern mortar. But the MIT researchers realized the Romans were doing something entirely different, something incredibly dangerous. The Romans weren't using safe, wet, slaked lime. They were taking completely dry, highly reactive quicklime and throwing it directly into the dry volcanic ash. Quicklime is pure calcium oxide. It is incredibly caustic and violently reactive. The ancient builders would mix these dry powders together first. Only at the very last second did they add water. The moment the water hit the quicklime, it triggered an aggressive, extreme heat chemical reaction. This is known as an exothermic reaction. The mixture would violently boil, generating temperatures so high that the water would instantly turn to steam. The heat was so intense that the quicklime couldn't fully dissolve into the mixture before the concrete began to set. And that is the grand reveal. This extreme heat is exactly what left those sloppy white lime clasts trapped inside the walls. They weren't the result of lazy workers. They were the deliberate byproduct of a fiery chemical explosion contained right on the construction site. By hot mixing their concrete, the Romans intentionally locked highly reactive, unmixed chemicals inside their structural walls. But why? Why would you want dormant, volatile chunks of calcium permanently frozen inside the walls of your most important buildings? What happens when a violent earthquake rips a microscopic fissure through that wall and a heavy rainstorm finally gets inside? This is where the genius of ancient Rome completely eclipses modern engineering. When a microscopic crack forms in modern concrete, it is a death sentence. Water seeps in, finds the steel, rusts it, and blows the wall apart. But when a crack forms in Roman concrete, a completely different chain of events occurs. The water seeps into the fissure, but instead of finding vulnerable steel, it hits those trapped, dormant lime clasts. The moment the water touches the white chunks, it wakes them up. The lime clasts dissolve, creating a hypersaturated calcium fluid that floods the crack. This fluid rapidly reacts with the surrounding volcanic materials. Within days, it recrystallizes as solid calcium carbonate. The crack literally glues itself shut before it can spread and compromise the structure. To prove this, the MIT team took a modern replica of Roman hot-mixed concrete and deliberately cracked it in half. They placed the broken pieces tightly together and poured continuous water straight through the crack. Within 2 short weeks, the water completely stopped flowing. The artificial stone had calcified and completely healed itself. Modern engineering spends billions of dollars every single year trying to invent chemical sealants, wraps, and coatings to keep moisture out of our buildings. We view water as the ultimate enemy of infrastructure. The Romans designed their concrete to use water as fuel. They didn't just invent a building material. They engineered an artificial, regenerative rock. They created a substance that lays entirely dormant until it is violently damaged, at which point the ingress of water triggers a microscopic chemical factory to heal the wound. Today, our modern obsession with smooth, perfectly uniform Portland cement comes at a massive environmental cost. The modern cement industry accounts for roughly 8% of all global carbon dioxide emissions. The industrial kilns require unimaginable amounts of fossil fuels to reach the extreme temperatures needed for production. Roman concrete requires significantly lower kiln temperatures to produce. And because it literally heals its own structural wounds, it lasts exponentially longer than the concrete we use today. You don't have to rebuild a massive bridge every 50 years if the bridge automatically repairs its own microfractures after every heavy rainstorm. Right now, material science startups are racing to commercialize this ancient hot mixing method. They are actively prototyping self-healing concretes based on the MIT findings, hoping to deploy this ancient chemistry to slash global carbon emissions. We may soon see modern roads, bridges, and seawalls built with the exact same chemical booby traps that hold up the Pantheon. We spent centuries looking down on ancient builders. We assumed our modern methods were inherently superior simply because we had better tools, complex computers, and sleeker designs. We looked at their greatest invention and called it sloppy. But the surviving ruins of Rome prove a humbling truth. Sometimes building the future doesn't require inventing something new. It simply requires admitting that our ancestors were much smarter than we are. History has a lot to teach us about the future. Subscribe to join the journey. What should we investigate next? Let me know in the comments. Thanks for watching.